To start out today's lesson, arithmetic sequences, you first need to know what an arithmetic sequence is. For a sequence to be arithmetic, it must have the same rule to each term. So the first thing that you need to do for your warm-up is to state whether each sequence is arithmetic or not. If it is, find the common difference and the next three terms. So hit pause and please do this. Now that you've hit pause, you probably saw that for part A, the rule was that you added 4 to each term. So yes, it was arithmetic. And the next three terms would have been 25, 29, and 33. For letter B, it also was arithmetic. The rule was plus 0.5. They added 0.5 to all of them. So yes, it is arithmetic, and the next three terms would be 1.25, 1.75, and 2.25. Because these ones differed, it went from plus 1/3 to plus 2/3. Oh, those are different, so no, it was not. So we just talked about an arithmetic sequence. It is a sequence where the terms ... differ by the same non-zero, it can't be zero, non-zero. So if it's zero, it's not allowed. Non-zero number. For example, here, from 12 to 8, the same way we get from 8 to 4, the same way we get from 4 to 0, what would you do? Well, you subtracted 4, subtracted 4, subtracted 4. So you would say that D, which stands for the difference, equals -4. D here, this was standing for, this was your common difference. What would be your seventh term in this? Well, you have 1, 2, 3, 4, so you have 12, 8, 4, 0, minus 4, you're now at -4, -8, -12, -16, so that's 1, 2, 3, 4, 5, 6, 7. So you would say that the seventh term equals -12. The way that you would actually write this is A sub 7 equals -12. What this means is the seventh term of an arithmetic sequence. So that's the way that you would write it. Instead of writing 7, you'd write A sub 7 equals -12. Take a couple of minutes and now keep going all the way to find the 25th term. So keep going, keep going. You can use your calculator. Subtract 4, subtract 4, subtract 4. Keep going, keep going. You should have ended up with A sub 25 equals -84. Now, I don't know about you guys, but that was kind of a pain to try and figure that out. We're going to watch a video here in a second to figure out an easier way. Real quick, though, the variable A is used to represent the terms in a sequence. A sub 3 is read A sub 3, and it's the third term. So to designate any term, the nth term, meaning any term, in a sequence, you write A sub n. Now to find that A sub n, we're going to watch a real quick video.
What is the formula for the nth term in an arithmetic sequence? Since we're looking for the formula for the nth term of a sequence, let's start by looking at a sequence and seeing if we can find a pattern. then maybe we can derive a formula from it. So let's look at the sequence 1, 4, 7, 10,
Please write
13,
this down in the
16,
space provided.
and so on. Let's break apart this sequence and see if we can find a pattern. So first, let's label each term in our sequence. So let's have a sub 1 be the first term in our sequence. So a sub 1 will be 1. Then we'll have a sub 2 be the second term in our sequence. So a sub 2 is 4. That means that a sub 3 will be 7, a sub 4 is 10, a sub 5 is 13, and a sub 6 is 16. Now looking at each one of these numbers, what do we need to do to get from one term to the next? Well, to get from a sub 1 to a sub 2, we need to add 3. To go from a sub 2 to a sub 3, we need to add 3. To go from a sub 3 to a sub 4, we need to add 3. So each time to get the next term in this sequence, we need to add 3 to the previous term. That means that the common difference of this sequence is 3.
And it's
That means
positive
that
3
D,
because it was
or the
added.
common difference, is 3. But we need to look for more of a pattern. So here's a trick. Let's make each one of these terms the sum of our first term plus something. So here, to get 1, we have 1 plus 0. To get our second term, we want to take our first term of 1 and add 3 to it. So to go and get 7, we need 1 plus 6. 10 is 1 plus 9. Then we have 1 plus 12 and 1 plus 15. Now look at all the numbers that we have to add to our first term. Each one of the numbers that we add to our first term is a multiple of 3, which is our common difference. So let's break these up into something times 3. Well, to get 1 plus 0, we have 1 plus 0 times 3. To get 1 plus 3, we have 1 plus 1 times 3. Then 1 plus 6 is 1 plus 2 times 3. Then we have 1 plus 3 times 3, 1 plus 4 times 3, and 1 plus 5 times 3. I'm seeing a pattern here. Each time we take our first term of a sub 1 and then add 3 times something. But how do we get that something? Well, let's look at a sub 2. To get 1, we can take our index of 2 and subtract 1. So 2 minus 1 is 1. Now let's see if that works for the other terms. A sub 3. We have 1 plus 2 times 3. To get 2, we take our index of 3 and subtract 1. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4, and so on. So that's a pattern that will work. Let's put that into a formula.
Please write
In
this
step
formula
2,
down.
let's take our pattern and write it out as a formula. And for this formula, we want the nth term. So we want a sub n. Now what is a sub n equal to? Well, let's look. For a sub 6, we need 1 plus our index minus 1 times 3. So say if we wanted a sub 10, we would need to take 1 plus 9 times 3, because 10 minus 1 is 9. So here we want to take the first term in our sequence, a sub 1, and add our index minus 1. So in this case, we want to take n minus 1. Then we want to multiply 3 to it. Well, 3 is our common difference. So we want to multiply the common difference to this number. Now we've made a formula to find the nth term in a sequence. But let's make sure that it's correct. So let's take this formula and plug it in to a sub 5 to see if we get the value that we want. So for a sub 5, we would have a sub 1, which in this case is 1, plus n minus 1. Here, since we're working with a sub 5, we would take 5 minus 1. And then we would multiply d. d is our common difference of 3. So we get 1 plus 5 minus 1 times 3, or 1 plus 4 times 3, or 1 plus 12, or 13. So we got the term that we wanted. That means that we found...
Okay, so you can see how we got the common formula. Please turn to the second page of your notes, and we're going to write this formula down one more time. It says the nth term of an arithmetic sequence with a common difference, d, and first term, a sub 1, is, and you should have written this down on the front, see if you can remember it, a sub n equals a sub 1 plus n minus 1 times d. Now let's label what these things are. Remember, a sub 1 is just the first, it's just your first term in the sequence. N is the term number you are looking for. And D is your common difference. Remember, it can be positive or negative based off if you are adding or subtracting. Let's do it. So example 2 says, find the indicated term of the arithmetic sequence. I put on here a hint. First, identify D, so I'm going to write D, a sub 1, my first term, and n. Well, if I'm looking for the 22nd term, I know that's n. A sub 1 is 5. Now, I just need to find the common difference. How would I go from 5 to 2, the same way from 2 to negative 1, the same way from negative 1 to negative 4? Well, I subtracted 3. Since you subtracted 3, it's negative 3. So when you fill it in your formula, a sub n equals a sub 1 plus, in parentheses, n minus 1 times d, and this is something that you need to memorize. You get a, instead of n, a sub 22, a sub 22, maybe, a sub 22, come on, equals a sub 1, which was 5, plus n minus 1, 22, minus 1 times the difference, which was, times your difference, which is negative 3. The first thing that you're going to want to do is your 22 minus 1. So you get a sub 22 equals 5 plus 22 minus 1 is 21 times negative 3. According to PEMDAS, we do 21 times negative 3. A sub 22 equals 5 plus negative 63. A sub 22 equals, when you add them together, negative 58. So we know, and you can always check by using your calculator, you know if you keep subtracting 3 the whole way and you get to the 22nd term, that it's going to be negative 58. Please go to the next video.